Hello students, I welcome you all to Engineers Academy. Do subscribe Engineers Academy if you haven't done it yet. Now we are going to solve this problem which says that a force of F, this is the Cartesian vector representation of that force F, which is 6I minus 2G plus 1K kilonewton, produces a moment of this much kilonewton meter about the origin point O. If the force acts at a point having an x coordinate of 1 meter, determine the y and z coordinates. Note that the figure shows F and MO in an arbitrary position. So we are given the Cartesian vector representation of MO. So MO, we can write that MO is equal to the cross product of force and moment arm. So now for this case we can define our moment arm from O to P. So this position vector from O to P is our moment arm. So we can say that this is ROP and cross product with that force F. So now this is given, this MO vector is given, and that is 4I plus 5J minus 14K, and this is equal to this, right? So we can find the position vector from O to P. So the position vector from O to P is, so we need to move from O along the x, y and z axis to reach that point P. So from O we need to move 1 meter in x, so that is 1 plus 1I. Then we need to move y units along J, so that is plus yj, and then z units along k, so that is plus zk. So now this is, we can write this as a determinant, so that is I, j and k, and then the components of the position vector from O to P, so that is 1 plus y plus z, and then the force, right? So the components of the force is 6, then minus 2, and then plus 1. 6 minus 2 and plus 1. So then we can find this determinant by considering this as plus I, this is minus j plus k, and then we will hide this and this. So this is y, and this is plus I into y into plus 1 is y, and then minus z into minus 2. Then we need to hide this column, and then minus j multiply by 1 into 1 minus 6z, this is 6z, and then we will hide this plus k, so then minus 2 minus 6y. So then this is, we can simplify it, this is, we can write this as y plus 2z I, and this is minus 1 minus 6z into j, or we can, if I multiply this, so this will be minus 1 plus 6z, so that will become plus. Similarly, we can write this as plus, and this is minus 2 minus 6y, and this is k. And now we have that MO which is given, so we can write it here. So this is 4I, this whole thing is equal to this. So this is 4I plus 5j minus 14k. So now if we compare the I component with the I component on both sides, so from this we can say that y plus 2z is equal to 4. So y plus 2z equals to 4, and then this minus 1 plus 6z equals to 5, and minus 2 minus 6y, this is equal to minus 14. So now here we have two variables, we can find the z from this. So this is 6z, and on the other side of equation it will become positive, so we will have it like this. So 6z is equal to 6, or we can say that z is equal to 1 meters. Similarly, from this, if I bring this minus 2 to the other side, so it will become plus. This is minus 6y minus 12. Minus will cancel out and y will be equal to 12 divided by 6, which will give us 2 meters. And now this third equation should verify our solution. So now if I put y equals to 2 and z equals to 1, so it must give us 4 meters. So now the force which is passing to this point P has a coordinates of x is 1 meter, y is 2 meters, and z is 1 meter. So these are the coordinates of that point P from which this force is passing. So this is the solution of this particular problem. I hope this will help you in your learning. Do subscribe Engineers Academy if it helps in your learning.